So section 6 is just some last two application things for percents. So we're going to do these two applications, then we're done. The first one I like a little bit more. And what they're doing, up until now, we've always had like the price increases by a certain percent, you figure it out, you're done. Or the price decreases by a certain percent, you're done. Or what's this percent of that number, then you're done. It's always been like a one thing. So the first new thing in section 6 is they're doing it twice. So they'll say, what's going to be the cost of something after this discount and then this increase, or this discount and this discount. So it's doing it twice, like one of your homework questions from last night. So because we're applying a percent twice, essentially you just do the problem twice. So do the problem twice. So you kind of go through it and do it the first time, and then your number from the first time through is going to be used in the second time you do the problem. So if we look at this one, I'm going to write out my original equation, percent times original equals new. Because please, my friends, if you're not getting these right and you're not writing that, start by writing that. So I'm going to say, all right, a $300 plane ticket has a 15% discount. So the original price is going to be the $300, right? Mm-hmm. So we're starting out at $300. So one trick in here is if they say a 15% discount, if you want to do it in one step, instead of doing 0.15, you do 0.85. Yep. Because, and just to review, you started out with 100% of the cost. They're taking off 15%, so you have to pay 85%. So we're trying to figure out what's 85%. What's the percentage we have to pay after they take off 15%? So if I do 0.85 times 300, that gets me down to $255. So after the discount, my plane ticket's $255. Good? Mm-hmm. Now, the second question, I'm going to just write my percent times original equals new. I'm going to pause a second and say, well, if we look here, they're starting out by saying, all right, they're going to take 15% off, and then they're going to make us pay 15% more. It seems logical that the final answer should be 300, right? Let's see if it is. If we take, all right, so they took 15% off, and that got us down to 255. So now we're starting at 255. So that's going to be my new original. Agree that's going to be what we're paying the 15% more on? So they took off 15%. Now we need to pay more on that. So if it's 15% more for luggage, instead of putting in 15% or 0.15, I'm going to put in 1.15 if you want to do it in one step. Because essentially we're saying you need to pay 100% of that 255, but they're tacking on 15% for luggage, so you need to pay 115%. Agreed? Yeah. And then before we put it in the problem, we take the decimal point and move it 2 places to the 1.15. So if I punch that in, instead of getting 300, I get $293.25. So taking 15% off and adding 15% back on doesn't get us right back where we started. Can anybody figure out why? She's exactly right. That initially we're taking 15% off of 300, which is going to be more off than adding 15% of 255 back on. So it's 15% of two different numbers. And because this is a smaller number, the amount we're adding back on is less than the amount we take off. So very good, very good. So be careful of those. I've seen people go through, 15% off, 15% on, cha-ching. They just write down the original number and smile and move on and get it totally wrong. So, all right, ready for example 2? Example 2 is going to be similar. We're just going to make one little change to it. So I'm going to start out with my equation, percent times the original equals new. So $64 increases by 13% to grow to $72.32. So I'm kind of like doing part of the problem for you. So we know that we have this 64. It's going to go up 13%. So in other words, they found 113% of it to turn into this. Good? So sometimes you'll actually have to do that first step in your problem. But then the tougher part is what percent decrease would return the cost back. So they're trying to say, if we're trying to get back to the 64, we need to minus what percent there. So where do I put my 64? Where do I put my 72.32?
64 original.
Well, 64 is the original the first time, but we're trying to figure out this going back.
72.
Yep, perfect. So my originals, we're starting here, right? So 72.32 is my new original. 72.32. And we're trying to figure out what percentage is going to change that into to make the new number of 64. Does that make sense? We're kind of going that red direction. And so because we're going from here to here, the original is that, new is that. So I'm going to put an X in for my percent. To solve for the percent, we divide both sides by?
72.32.
Perfect. 72.32.
72.2.
72.32. And if I look in my notes, so I came up with an X equals 0.885. And you know that 0.885 is what percent?
88.5%.
Okay, 88.5%. So are we done? Is that the percent decrease? Go for it, Katie.
No, it's, you have to take 100 and subtract 88.5.
Perfect.
And that's the percent decrease.
Perfect, yep. That here is what we pay. So we need to pay 88.5%. So to figure out what they took off, we do this here, and we get 11.5, I believe, 11.5%. So they took 11.5% off to get us back to that starting amount. Any questions on those? Cool. Simple interest. Simple interest comes up a lot in math classes. It's a nice way to apply it. Most of the time in real life, though, they do compound interest. How compound interest works, so if you have money in a savings account, maybe every 3 months they give you some interest in your account. That money goes in with your money, the interest that you made, and now you're gaining interest on your money plus whatever they gave you in interest. That's compound interest. That's how most things work. Simple interest is they just give you interest one time kind of at the end. It's not, you're not getting interest on the interest. But I'm going to write the equation real big here. I equals P times, so capital I equals capital P times lowercase r times lowercase t is usually how they do it. In capital I, a wise person would guess, stands for the interest. I can't say interest and spell it at the same time. E-R-E-S-T. Interest. P is the starting amount. It's kind of like the original in what we've been doing. So it's the principal. Usually I've seen it spelled that way for money. Sometimes you'll see it P-A-L, but that's more like principal in the office at school. So starting amount. So I'm not real picky on the spelling. R stands for the interest rate. Yep, so interest rate. And for that, we put it in like we've been doing the other one, so it'll be a percent as a decimal. So if you're getting 10% interest, it'll be 0.1 or 0.10. If you're getting 3% interest, it'll be 0.03. And the last thing, T is going to be time. And for that, usually it's going to be years. I'm going to put in parentheses same units as interest rate period. Typically, they're going to say you get this much interest a year, in which case then time would have to be the number of years. So if it's 5 years you have it in the bank, T is going to be 5. If it's 6 months that it's in the bank, then T would be, 6 months is how much of a year? Half of a year, so 0.5. It's 6 out of 12 months, so 0.5. If they were to give you like the interest like so much a month, then if they say 1 year, you'd have to put in a T of 12, because it'd be 12 months in a year. So just be a little careful. Typically, those will both be years for the interest rate and the other. So, number 3, if you borrow $40,000 for college at 3% interest for 6 years, how much interest will you pay? So I equals P times R times T. So 40,000 goes in for the P, yep. So that's the principal. Goes in for 40. Goes in for P. 3% interest, so I'd write a 0.03. Nice. So times 0.03 goes in for R. And I guess I didn't specify, so I'm going to just assume it's 3% a year. So then T would be 6. Cool. So if we punch that in, we should get 7,200. So does that mean if you borrow $40,000, you only have to pay back 7,200? That'd be awesome. Unfortunately not, but that's the interest. So the amount you have to pay back total is going to be, exactly, because you still have to pay that $40,000, but you have to pay the bank $7,200 for loaning that to you. So your total bill is going to be $47,200. Some are worse than that. Oops, took off a little more than I wanted to.